Here we go with binomial probability, our last lesson. A binomial experiment, you can read right here at the top of the notes, occurs if and only the following conditions apply. There are exactly two possible outcomes. That's where that bi prefix comes into play. Either you have a success or you have a failure. The success will be designated with probability P, a failure with 1 minus P. There is a fixed number of trials, and the trials are independent. In other words, we're going to repeatedly go through an experiment. Perhaps we're flipping a coin. We might flip a coin 10 times or something like that. So that's where we'd say a fixed number of trials. And the probability of each trial is the same. So this formula right here is super, super, super helpful. This is our number one go-to tool. And it would say, if you'd like to have K successes in N trials, you might say, look, either you have a success or a failure, but we're going to repeat this experiment over and over and over. In N trials, if you'd like to have K successes, this notation, of course, is the combination of N things taken K at a time. Because I want to have K successes, we're going to take P raised to the K power. And if you don't have a success, you'd have a failure. That's 1 minus P. That's going to be raised up to the N minus K power. A very important note I want to tell you is that these two powers must always add up to the total number of trials. Some of your trials will be successes. Some of your trials will be failures. So using this formula, we're going to be able to take a look at some problems. Let's look at example 1. It says Dwight is taking a 10-question multiple choice test. If each question has 4 choices and he guesses on each question, definitely not something that you want to have happen. But here's Dwight. He obviously didn't study. He's got 4 choices. He's like, okay, I'm going to pick one. What's the probability that on this test he will get exactly 7 questions correct? Well, let's think about this. P would be considered success. This would be, a correct answer. What do you think P is going to be here? Well, how many answer choices does he have for each question? 4. What do you think we'd have then? 1/4. He's always going to have 4 possibilities, but only one of those possibilities will be correct. He's going to have a 1/4 probability of just guessing and seeing a problem is right. Now, the failure would be getting a problem wrong. Guess what that probability would be? 3/4. He is 3 times more likely to get a problem wrong. Remember, he's just randomly guessing. So they're saying, look, the trials, you could say that he's not going to just guess on one problem. Sadly, he's going to guess on the whole test. There are 10 questions. And you could say, what's the probability that he's going to get 7 correct? Now, there are different ways you can do this. You can make a tree. You could write out all the different possibilities that you could find this to work out. But guys, that's not the powerful way to do it, especially with 10 trials. Here's what we need to say. The probability of 7 questions correct, well, let's see if we can work that out. It's going to be a combination. What do we have up on top, guys? 10. There are 10 questions. Out of 10, choose how many of them? 7. We want 7 correct answers. And then we could say, well, what's the probability of getting a problem correct? We'd get 1/4. And raise that up to the 7th. He's also going to get some problems wrong then. 3/4 is going to get raised up to what power now? The 3rd. Obviously, if Dwight gets 7 questions correct, he's going to get 3 questions incorrect. He's going to get 3 questions wrong. So now we're going to see just how likely this is that he's going to get 7 correct. Do you think it's going to be likely or unlikely? What do you think? Probably unlikely. Take your calculator out. Let's see if we could work this out together, right? We could say, well, 10 choose 7. We could go 10, math, go to the left for probability. That's the quick way, NCR. We'll say 10 choose 7 times, well, if you want to do 0.25 to make this go a little bit quicker, you can raise that up to the 7th, times, well, now we'll take 0.75 and raise that up to the 3rd. And hit enter, and you can see that's not very likely, is it? That's not very likely. Someone just guessing to be able to get 3 problems correct. Now, you could try to see if perchance we can turn this into a fraction. Very often we cannot. So let's say we were going off to the nearest hundredth, or well, nearest hundredth, nearest thousandth perhaps. We could say that's 0.003, right? So just a 0.3% chance that that would happen. Okay, which we'd expect that to be pretty small. Any questions on that so far? The alternative would be to write out the 10 questions and say, hey, which 7 will this guy get correct? Guys, there's so many different ways that could happen. Tons of different ways that could all work out and work out all those probabilities. That gets to be exhausting. Definitely not a lot of fun. This is definitely the way to do it. Let's take a look at number 2. Number 2, hey, the World Series starts tonight. It's appropriate to have the baseball problem. Batting averages, right? Batting averages could be thought of probabilities. What is the probability that this hitter is coming up and will get a hit? So Luis Gonzalez, he was a real player. He played a number of years ago. Has a batting average of 0.300. 300 batting average. That's a good batting average for a baseball player. Find the probability he will get, here's a word we're going to see a lot, at least 2 hits in the next 5 at-bats. Well, we could begin to talk about this. The probability of a success would be getting a hit, of course. We know that is 0.300. What's the probability of him not getting a hit? 0.700, or just 0.7, right? So it's far more likely that when this man goes up to bat, he's not going to get a hit. Well, that's all well and good. This is not quite the same problem that we had before. When you'd say that he should get at least 2 hits, that little phrase, at least, is really opening the problem up quite a bit. What are we really talking about? He could get 2 hits, or what else? 3 hits, what else? 4 hits, or the very, very unlikely situation of getting 5 hits. Usually when a baseball player does that, you'll be hearing about that on the news, regardless of where the player is from. It could be a different team very far away. Wow, this player got 5 hits in that night. So my goodness, right now that's looking at 1, 2, 3, 4 different cases. 4 separate probabilities that you could add together. And that is certainly one way you could use the binomial theorem. You could say, look, out of 5 trials, choose 2 and work that out. Do the same thing for 3, 4, and 5. Add up all those probabilities. I should say the 4 separate cases, maybe I misspoke. The 2 hits, 3 hits, 4 hits, 5 hits. And that's certainly valid, and you can do that. Yes? No, I'd love for you to make a suggestion.
Can't we just figure out the probability of getting 1 hit and then do 1 minus that?
Yeah, even also, what else could happen? The one hit or no hits. You see, when we're looking at the negation, and that's what many mathematicians would call the backdoor approach, you'd say, look, why is that preferable? How many cases do we have there? Just 2. So we could say, well, look, Luis might get 0 hits, or he might just get 1 hit. Now, very quickly, people are going to say, well, that's not what they're asking you. They're not saying what's the probability to get 0 hits or 1 hits. But we know in a probability distribution, all of these cases have to add up to 1. So if I could add these 2 cases together, fewer cases to deal with, then subtract that from 1, then I'm dealing with the at least situation. So that's definitely preferable. So we could say this would be not 10, but 5 choose 0. What's my probability of getting a hit then? We know it's 0.300 to the 0 power. Here's 0.700 to the 5. Right here I'd get 5 choose 1 and take 0.300 to the 1. Go 0.700 to what power now? To the 4. And you know what we could do real quickly? We could even say, hey, how about we add those together, and then we'll say 1 minus the answer to work that out. So tell you what, we could do all of this quickly off to the side and say, well, let's see if I wanted to do 5, NCR, choose 0, times, well, you know, 0.300 to the 0 is 1. I think it's just as well to say I'm dealing with 0.7 to the 5th. That might be the easy way to do it. Then I'll say plus, because I'm going to add that case together. I'm going to say 5, NCR. And I'm just going to choose a 1. Now I'll say times 0.3. We don't have to put all the zeros out there, to the 1. It's almost silly to do that, isn't it? Times 0.7 to the 4. And guys, when you do that, you'll get the probability that Luis either gets 0 hits or 1 hit for that evening. That would be 0.52822. So we could say all of this works out to 0.52822. And when we subtract that 1 minus the 0.52822, that's really the answer that we would like to come up with. We can just say 1 minus second answer, second negative, and we should get 0.47178. That's the probability then that this baseball player might get 2 hits, 3 hits, 4 hits, or 5 hits. Are we doing okay? All right. Well, guys, let's see if we could just take a quick peek at this last problem. A thumbtack is dropped. The probability it lands up is 0.4. That means the probability it doesn't land point up would be 0.6. So if 12 tacks are dropped, here's that repeated trials. You know, all of a sudden this isn't happening for 1 thumbtack, it's happening for 12. Find the probability, oh, look at this word. At most, 2 thumbtacks are pointing up. Now, the phrase at most will imply what? We could get 0, 1, or 2 tacks up. If you'd say, I want at most, it means 2 would be considered valid, but you don't go beyond that. You could go smaller than that. So we would want to find the probability of 0 plus the probability of 1 plus the probability of 2. Here, the backdoor approach really wouldn't be so helpful, would it? The backdoor approach would be way more cases, like 3, 4, 5, all the way up to 12. And guys, all you have to do here is just, finish that up, and I hope that's not too bad. Let's write out the binomial theorem for each of these. What do you think it would be? How many trials do we have? 12. So 12 choose